Welcome back to Security for Legal SaaS. I'm Alice.
And I'm Dan. Episode 50, Developer Workstation Security. Alice, we've spent the last several episodes on cloud infrastructure, deployment pipelines, and IAM permissions. But today, we're zooming in on something much more personal, the actual laptop sitting on a developer's desk.
And it's the thing most teams harden last, if they harden it at all. Think about it this way. Your production servers are behind firewalls, intrusion detection, strict access controls. Your cloud IAM policies, which we covered last episode, enforce least privilege. But the developer's laptop? It has an SSH key that connects directly to every one of those environments. It has saved browser sessions to the cloud console. It has .env files with database passwords in plain text. And it probably has antivirus that hasn't been updated since it was first set up.
So the laptop is basically the keys to the kingdom, sitting on a desk in a coffee shop.
That's not even the worst version. The worst version is the laptop sitting on the desk of someone who just left the company. But yes, a security researcher at CSO Online described developer workstations as the new beachhead. 3 separate threat actor groups independently decided that the developer laptop was the single best entry point into an organization. Not the servers, not the cloud, the laptop. Because the value of what's on it is enormous, and the security around it is often minimal.
Right, can you give us a real example of this going wrong?
The CodeCov breach. CodeCov was a code coverage tool. It tells developers how much of their code is tested. Attackers compromised a script that ran inside developers' build pipelines. For 2 months, that script silently collected environment variables, things like API keys, cloud credentials, authentication tokens, from every customer who used it. Federal investigators found the attackers then used those stolen credentials to break into hundreds of downstream companies. The developers never knew. They ran their normal build process and it sent their secrets to the attacker.
2 months undetected. And for a legal tech team, what's actually at risk on a developer's machine?
Let me walk through it. SSH keys, those are the cryptographic keys that let developers log into servers remotely. If stolen, the attacker gets direct server access. Cloud console sessions, developers stay logged into AWS or Azure in their browser, and those login sessions can be extracted from the browser's storage and replayed from any other machine. Source code, which may contain hard-coded secrets in older versions. .env files, configuration files with database passwords, API keys, all in plain text. And here's one people miss. If your developers are building a document review tool or an e-discovery platform, they might have test datasets on their laptops that contain real client documents. A workstation compromise becomes a client data breach, and that triggers notification obligations under ABA rules and state law.
Yeah, that's a hard one. Real client documents on a test machine. What about browser extensions? I've heard you mention those as a risk.
Browser extensions are uniquely dangerous. An extension with broad permissions, and many request access to all websites, can read the content of every page the developer visits. That includes cloud admin consoles, code repositories, internal dashboards. It can intercept form submissions, capturing passwords as they're typed. It can modify what the developer sees on screen. And it can send data to external servers without triggering any of your network security. A developer who installs a random productivity extension has basically given a stranger read access to every authenticated session in their browser.
So what's the fix? What does a properly secured developer workstation look like?
Start with the basics. Full disk encryption, FileVault on Mac, BitLocker on Windows, LetPass on Linux. Non-negotiable. If a laptop is lost or stolen, encryption means the data is unreadable without the key. The Center for Internet Security lists this as a level 1 control, the bare minimum every organization should have.
Right.
Next, replace file-based SSH keys with hardware security keys. We talked about FIDO2 keys back in episode 21. The same hardware keys that protect your login can store SSH keys in tamper-resistant hardware. The private key never exists as a file on the laptop. Even if the machine is fully compromised, the attacker can't extract it.
And cloud credentials.
Stop using long-lived access keys. Use single sign-on with session tokens that expire in hours. AWS has IAM Identity Center for this. The idea is no persistent credentials on the file system. If there's nothing to steal, a compromised machine gives the attacker a much smaller window.
Oh, what about the AI angle? Developers are pasting code into AI assistants all the time.
This is a newer risk. Developers routinely paste error messages, configuration files, and code snippets into AI coding tools. If those snippets include API keys or database connection strings, that data is now on a third-party server. Even if the AI provider says they don't train on your data, it still traversed their infrastructure. The fix is policy and tooling. Use locally hosted AI for sensitive work, and set up pre-commit hooks. Those are automated scripts that scan code before it's saved, to catch secrets before they get committed.
Yeah, and offboarding when someone leaves.
Revoking their Git access is about 10% of the job. You need to rotate every credential they have access to. SSH keys, cloud IAM roles, API tokens, database passwords, CI/CD secrets, the automated deployment pipeline credentials. If they used a personal device, wipe the corporate data remotely. The developer may have had credentials cached on that machine for months. If you don't rotate, those credentials still work, and you'll never know if they're being used by someone they shouldn't be.
So, to summarize, disk encryption, hardware keys instead of file-based SSH keys, short-lived cloud tokens, browser extension controls, endpoint detection software, pre-commit secret scanning, and a real offboarding process.
That's the minimum. And the principle behind all of it is assume the workstation will be compromised, and make sure that compromise gives the attacker as little as possible. No persistent credentials to steal, no plain text secrets on disk, no browser extensions with God mode permissions. Your production infrastructure can be hardened perfectly, but if the laptop that accesses it is wide open, that's where the attacker walks in.
Next episode, what happens when the developer writing your code is itself an AI? Verifying agent-generated code and the risks of hallucinated dependencies.
Until then, I'm Alice.
And I'm Dan.
Security for Legal SaaS is a series written with AI assistants. Alice and Dan are AI-generated voices. No professional advice here, just education.